Good morning, everyone. I am M. Ramesh, Assistant Professor in the Department of Aerospace Engineering. In today's session, we are going to discuss an important topic classification of composite materials. We will begin with a brief introduction to composite materials and then explore their various classifications based on the matrix reinforcement and structural form. We will also understand how different types of composites are used in various engineering and aerospace applications. So in this slide, we are going to discuss the classification of composites. Generally, composite materials are engineered materials formed by combining two or more different materials that remain physically and chemically distinct with the final product. The purpose of combining these materials is to obtain improved properties that cannot be achieved by using the individual materials separately. A composite material generally consists of a matrix and a reinforcement. The matrix is the continuous phase that surrounds and supports the reinforcement, while the reinforcement is the stronger or stiffer phase that improves the mechanical and other functional properties of the composite. The interface between the matrix and the reinforcement plays an important role in transferring the loads and determining the overall performance of the material. The matrix may be made of polymer, metal, ceramic, and carbon, while the reinforcement may be in the form of fibers, particles, flakes, or viscous. For example, in a carbon fiber reinforcement polymer called a CFRP, carbon fibers provide the high strength and stiffness, while the polymer matrix holds the fibers in position and transfers the applied load between them. Similarly, in concrete, cement acts as the matrix and aggregates such as sand and the gravel act as reinforcement. The combination provides a material with a high compressive strength and a good structural performance. Based on the material used as the matrix, composites are classified into polymer matrix composites, metal matrix composites, ceramics matrix composites, and carbon-carbon composites. Polymer matrix composites use polymers such as epoxy, polyester, and vinyl esters as the matrix and are reinforced with glass, carbon, or aramid fibers. Metal matrix composites use metals such as aluminum, magnesium, titanium, or copper as the matrix and are reinforced with ceramic particles or fibers. Ceramic matrix composites consists of ceramic matrices such as silicon carbide or aluminum reinforced with fibers to improve the toughness and resistance of to the thermal shock. Then carbon-carbon composites consist of carbon fibers embedded in a carbon matrix and are capable of operating at extremely high temperatures. Metal matrix composites are advanced composite materials in which a metal or metal alloy acts as the matrix, while the second material, generally in the form of particles, short fibers, continuous fibers, or viscous, acts as the reinforcement. The main purpose of producing a metal matrix composite is to combine the useful properties of metals such as ductility, toughness, electrical conductivity, and ease of fabrication with the superior properties of the reinforcement materials such as high strength, stiffness, hardness, wear resistance, and thermal stability. In a conventional metal alloy, the properties are mainly controlled by alloying elements and a heat treatment. In a metal matrix composites, the properties can be tailored more effectively by selecting the appropriate matrix, reinforcement material, reinforcement size, reinforcement volume fraction, as well as the distribution. The reinforcement generally carries a significant portion of the applied load, while the metal matrix transfers the load to the reinforcement and provides the structural continuity. A typical metal matrix composite consists of a continuous metallic matrix and a discontinuous or continuous reinforcement phase. Aluminium, magnesium, titanium, copper, and nickel are the commonly used matrix materials. Reinforcements include silicon carbide, aluminum oxide, boron carbide, graphite, carbon fibers, boron fibers, and viscous are the reinforcements. Next is ceramics matrix composites. These are all the advanced composite materials in which a ceramic material acts as the matrix and which is reinforced with the fibers and viscous particles. Conventional ceramics such as alumina, silicon carbide, and silicon nitride possesses the excellent hardness, high temperature resistance, and corrosion resistance, and low density. However, they are generally brittle and have a fracture toughness. The main purpose of developing ceramic matrix composites is to overcome the brittleness by incorporating a suitable reinforcement into the ceramic matrix. A ceramic matrix composite generally consists of a continuous ceramic matrix and a reinforcement phase. The matrix provides a high temperature stability hardness, oxidation resistance, and environmental resistance, while the reinforcement improves the fracture toughness, damage tolerance, and resistance to the catastrophic failure. The reinforcement also helps control the propagation of cracks through the material. Common ceramics matrix materials include silicon carbide, alumina, silicon nitride, and mullite. Common reinforcements include silicon carbide fibers, carbon fibers, alumina fibers, ceramic particles, and viscous. So that's all about in today's session. We will see important topic in the next session. Thank you all.